Afternoons are ideal. Sir, we're working on a solar and wind energy harvest regulator circuit with two inputs and a single output. The solar panel, the PV solar panel, is of 0 to 21 volt DC, as in one output, while the wind turbine is the other. It is of 15 volt DC, and the circuit has to be able to able to charge a 12 volt battery. The output current produced to fully charged battery must not exceed 3.5 ampere. My group and I acquired a few circuits from our teacher, Professor Smriti Nayak, and simulated them using Proteus, resulted in a 3.5 ampere output current. Then we developed this on a breadboard. Now, talking about the design, this concept allowed a battery to be charged simultaneously by two sources of energy, such as wind and sun, without the need for physical intervention. Like there is no need of getting charged it, like charging it using your domestic electricity. So it is totally a natural way of charging your battery. The PWM paradigm is used in the above design. The circuit shown here has the same capability, namely, it allows a battery to be charged from two distinct sources while maintaining an extremely straightforward, efficient, low cost, and hassle free design. So, let's understand how the circuit works in details. So, the parts what we used for this dual hybrid battery charger circuit is we have used 10K resistors. We have 1 by 2 watt Zener diode. We have 3 volt or 3.7 volt Zener diodes. So, we have a capacitor of 100 microfarad, 25 volt, and we have two transistor TIP 142, and the third one is BC507. We have another diode 1N4007, one red LED. We have two red LEDs, and we have a diode 1 of 10 ampere rectifier diode or Schottky diode, we can say. So we have another op-amp which is LM358. These are all the specifications, and now let's look at how it is going on. So the proposed solar wind twin hybrid battery charger circuit is shown in the diagram, which we have shown there here above, which uses common elements like op-amps and transistor. On the left side of the battery, we can see two consecutive op-amp stages. On the right side of the battery, we can see two identical op-amp stages. The wind energy source is absorbed and controlled by the left side op-amp stage, while the solar electricity is used by the right side op-amp stage for charging the single common battery in the middle. Although the two stages appear to be the same, the way of regulation are not. The wind energy controller circuit manages wind energy by stunting or sorting excess energy to ground, whereas the solar processing stage does the same thing, but instead of sorting, it cuts the extra energy. So how the op-amp is configured to function. Now let's look at how the op-amp stages work by looking at the following points. The op-amp are used as a comparator with pin with the third number of pin non-inverting input, serving as the detecting input